Well, I guess it's 12. Welcome to those of you that are joining us online and live, and welcome to those ones that will be joining us later through the YouTube channel and the replay. My name is Christy Keys. I am the county agent or the extension agent, actually, for agronomy for Castro, Hell, and Lamb County up in the Texas Panhandle. Dr. Dana Porter and I have put on this Irrigation Excellence Conference for you to learn more about irrigation and water management because it's such a critical source for us here in the High Plains. We are excited that you are here. If you are live and you have a question, feel free to unmute or to put it in the chat. I will be watching that as we progress through this today. And if you have questions and you're watching it after the fact, please feel free to email myself or Dana Porter with your questions and we can get them answered. I will turn it over to Dana to start today's discussion.
Thank you, Christy, so much. I appreciate y'all hanging with us. This is the 5th, can you believe it, in the series, in the Ag Water Management series, and really appreciate Christy's work on promoting and recording and doing all the hard work, heavy lifting on this project. So I really appreciate you guys being here. Again, we are Christy Keys and Dana Porter, and you can find us in the AgriLife directories, and certainly a lot of our viewers later on will know how to find us, but we welcome questions, as Christy said. I just want to acknowledge really quickly our sponsors. This is what pays the bills so that we can do our jobs. We look at USDA Agricultural Research Service Ogallala Aquifer Program, the USDA NIFA Hatch Act, and High Plains Underground Water Conservation District. So we really appreciate the support that helps us do our jobs. Today, we're going to be talking about a couple of topics: irrigation economics, just a little background there, and some emerging technologies. Why do we irrigate? That's a question that we get sometimes. If we want to save water, why are we using the water for irrigation? Well, really, it comes down to economics. According to Suat Irmak, a paper that he wrote, I've got that cited in a future slide, irrigation on 20% of the cultivated land in the U.S. produces 40% of the total 24% of cultivated land in the globally produces 40% of the total global food supply. So we get a lot higher yields with irrigated crops, and so that is why we irrigate. Irrigation is a risk management tool, a risk mitigation tool. So we mitigate the negative impacts of drought and unpredictable, unreliable rainfall so that we can have greater yields or maintain more reliable yields, as well as product quality and profitability. Excuse me. Oops. Yield advantage is just that paper that I cited there. Suat Irmak and Meetpal Kukal. They are Suat Irmak and Meetpal Kukal were both at University of Nebraska when they wrote this, but Suat is now at Penn State University, department head there, and Meetpal is an irrigation researcher at University of Idaho. So we really appreciate their contributions. But this just produces this graph indicates relative advantage of irrigation over rain-fed or dryland crops. So you can just kind of see the importance, the relative importance to corn, spring wheat, winter wheat, alfalfa, cotton, sorghum, the major crops there. So that's why we irrigate. We get higher yields. The link to the paper is right there. This is an open access paper, so you can get access to the whole thing. Again, presenting by crop and over time, the yield advantages of irrigation have increased over time, with the greatest increase in cotton production, believe it or not. Now, there are several things here. One is certainly irrigation technologies have improved. Irrigation management has improved. We're doing a lot better job of managing our water, but we also have to acknowledge that varieties and genetics and other management, the integrated crop management practices have improved as well. But we look at the differences between irrigated versus rain-fed, increasing over time. The slope of the curve shows the progress we've made. Again, the steep curve with cotton, you look at winter wheat, corn, all of these crops, we see really good advantages of irrigation, again, increasing over time. Some economic considerations when we're looking at whether to irrigate and then what technologies, what practices to adopt. Certainly we want to look at yield response to irrigation. And that was those curves that I showed you. If we have an economic advantage, we get a good return on investment of yield or market value of our crops over dryland, then that's an incentive to irrigate. That risk management value. So if I can usually have a crop, but I hit that dry year or 2 or 5, this really helps to mitigate those drought-induced losses for us. Market prices, a lot of times with irrigated crops, the quality or the timeliness can be better. So that affects the marketability and pricing. Maybe we get a premium on higher quality products such as cotton, or we can avoid dings. We can avoid negative impacts of diminished quality that we might see in a drought situation. Cost of irrigation, this changes a lot, fixed and variable costs. So you have the cost of the equipment itself, whether it's the center pivot, the hardware you're putting on top, and the pipelines and the motors and all that. But we also have variable costs with energy, the cost of labor, the cost of repairs. Equipment's expensive, maintenance and labor are expensive. Energy varies a lot. It tends to be pretty pricey, but the cost of, for instance, natural gas varies quite a bit with time, as does electricity, a little bit less so, but diesel and natural gas can vary quite a bit. Again, I said that return on investment. We put all this cost in there into our system, all of our inputs, including, if you stack on top of seed cost, fertilizers, pest management, insecticides, herbicides, all of that, we've got a lot invested in a crop. So we want to make sure that whatever decisions we're making, we're going to get a return on that investment. And of course, we have long-term considerations and land values. If I have an irrigated land, it's going to be generally valued higher than a dry land farm. If I have more water or let's say a deeper, a thicker, a saturated thickness in my aquifer, that land may be valued higher than land that's not as replete with water resources, right? A couple of tools I wanted to show you in case you haven't seen these before. The Texas A&M AgriLife Extension Agricultural Economics group has put together some really good resources, free. We always talk about free, right? Don't we, Christy? But anyway, they have some crop budgets by district and by crop and by year. And you could go in and find basic budget guidelines. You can also use some spreadsheet to create your own budgets. But these are pretty good indicators of how much irrigation farmers are typically putting on different crops within a region. Of course, each grower, things are going to vary with each operation, but this gives us a pretty good place to start as far as estimating what those costs are. Kind of show you an example here. This is for irrigated corn for grain with a sprinkler irrigation system. This is the budget that they were using for 2026. So you see the cost of the custom operations that they might have, fertilizers, herbicides, down about halfway, most of the way down, you end up with, well, halfway down in that group is irrigation. So you've got energy costs and irrigation labor, machinery costs, all of that, though, you can see in that table. But they typically in that District 1, they're expecting to put about 22 inches of irrigation on that corn crop. What they expect the cost, $5 per acre inch, and then they estimate a cost then. So you can see how you might use this as a good starting point. Of course, they also set, they have at the bottom expected returns, and to be able to break even, you need $5.61 per bushel. So anyway, it's a pretty good tool. Mary Beth Day, our new extension economists at Amarillo, I guess Canyon now, has some really good ideas for you. But I like that resource. I'm going to show that to you again, where you can find that. If you just Google AgriLife crop budgets, it'll take you to that page. We appreciate their contributions. Another good resource that I like to use is offered by Kansas State University. Their mobile irrigation lab was developed by one of my colleagues many years ago, but they've continued to add tools on it. Their website is shown there in my lab. That's mobileirrigationlab.ksu.edu. One of their tools is their crop water allocator. I like to show this one because it allows you to enter acres, what your costs are, what your inputs are, your soil type, your prices, your expected yields, and then it kind of comes up with how much, if I wanted to try to figure out maybe a split pivot, half cotton, half corn, or something like that, it can help me identify what the optimal or what the expected return on that investment is. So, okay, so I've got that crops and prices. Again, I can input how much water I'm going to put on, my discharge rate, my pumping, all of that stuff. And then it'll spit out some examples. If I grow all corn, I might get a total return on $42 per acre. If I slip down to the bottom, I could be losing money if I grew all sorghum, right, and tried to irrigate with it. So I can just kind of play that what if game by plugging in different scenarios, different crop mixes, different rotation mixes to get a ballpark of what my optimal crop mix might be. So I encourage you to check that out. That's Crop Water Allocator at Kansas State University Mobile Irrigation Lab. Also giving more credit to Kansas State University, their Compare Energy Cost tool. This one gives you an idea. Maybe I'm considering going from natural gas to electricity. I can plug in numbers, estimated costs of what I'm paying at today's natural gas price, and it'll plug in equivalent cost. It'll show me equivalent cost that would generate the same amount of pumping, basically water horsepower for pumping. So now the shortfall of this tool is that it assumes that your pumping plant is performing at Nebraska pumping, their recommended Nebraska pumping test lab numbers, which means it's a fairly well-performing system. If my impellers are worn out, if my system is not as efficient, my costs are likely to be higher than that. But anyway, this gives you a pretty good start. I've also used it as kind of a backdoor sometimes. If I plug in what I'm actually putting in, what my costs actually are, and I can compare them to the energy cost that it's calculating. If I'm spending way more per acre inch than what the calculator says, then it means I'm probably not as efficient as I should be. So it might be time to have my pump looked at. Okay, again, that is the Compare Energy Cost tool at the Mobile Irrigation Lab. So I just wanted to let y'all know about it. Another tool I'd like for you to be aware of is USDA Natural Resources Conservation Service. Perhaps you're familiar with their Environmental Quality Incentives Program, or we call it the EQIP program. They have payment schedules posted by state on their website. So you can go to this website and find, for instance, if you're in Texas, you can find the Texas payment schedules. You can even go by county and find out what those technologies, practices, and so on will yield for you if you want to participate in those NRCS. So it gives you an idea. Again, it's also a ballpark estimate of what things cost if you're just curious about cost. So I encourage you to look at that, the USDA NRCS EQIP cost share payment schedules. Now I'll jump a little bit more into the irrigation technologies, some new and emerging technologies. Hopefully many of our audiences will already be familiar with a lot of these. But to start with, irrigation controllers and system monitoring technologies. These have come a long way since I started working in irrigation many years ago. But most of our major equipment manufacturers and even some public and private sector groups offer packages to monitor and control irrigation equipment. So with your cell phone or your iPad, you can look at which of your systems are running, what their status is, what a lot of times you got the flow meters hooked up to it. So I can find a lot of information. If I'm having trouble with one of the center pivots, well, I know which one to go to service it and prioritize that. So it's really handy, especially for people who have multiple farms that they're trying to manage, and they can see all of this information really on their phone. It's an internet-based dashboard visualization tool. They have smartphone apps. They have standalone systems. I can get third-party systems that will work with our major manufacturers' controllers. So there are a lot of options available for you. Some other technologies, variable rate irrigation has gotten a lot of attention in recent years. It may or may not be economically feasible. It depends, again, on your particular system and your particular operation. Programmable controllers. These are, I can decide ahead of time how much to irrigate, go ahead and set my program. And I have sensor-based controllers. A lot of these are on the market already, and many of our growers are using some of these. Some other things that if you want to go basic systems to really, really fancy, you can get remote system monitoring and control. There's one company offers a system that they can even monitor if somebody's still in the wiring off your pivot. So you can call the sheriff while the guy is still stealing your wire, so it gets catch him. So they've got stories out there, lots of products out there. Some other things that hopefully many of you are aware of. If you're not, basically these are not my granddad's technologies, right? That things have changed a lot over the years, but we have a lot of wireless sensor networks. Instead of just having a soil moisture sensor, for instance, out in the field where I have to go plug in a meter and take the data, now those are wireless sensor networks connected with telemetry. I can gather the data centrally to a computer, get it on my phone, put it up in the cloud, I download it on my phone or my computer, and I don't have to go marching out into the field to take data anymore. That's really nice to have those. Also, I can get a lot more data. I could have more sensors without a bunch of wires in the field. So that's really handy too. Some other things are really helpful, the automated integration of data from multiple sources. So what if you have soil moisture sensors and canopy temperature sensors and maybe some weather station sensors? I can get information from those various sources, automatically put those into models, machine learning to help optimize the system, and even come up with some variable rate irrigation improvements. So many of these things are available. Others are in the pipeline and hopefully will be ready soon. Again, the automation of irrigation controllers. If I have all these data and the models, I can get some expert system help with knowing how much and when to irrigate. Again, a lot of system research programs that I'm going to talk about these a little bit more in a minute, but the machine learning and the models to help optimize irrigation scheduling. So the what if plans that we play with pencil and paper, what if I irrigate, what if I don't irrigate? These can be automated and integrated into our controllers. So that's kind of handy. Variable rate irrigation, you may have heard some about this. A lot of people are using it. Many of our center pivot manufacturers offer variable rate irrigation packages, including everything from relatively simple control boxes to really fancy variable rate irrigation zone control. If you have a speed control on your pivot, which most people do, then you have some built-in variable rate irrigation capabilities already. So I just kind of on that top circle there, looks like a pie chart. If I have different, for instance, different crops or different soils within that pivot, I can run different parts of the pivot at different speeds, putting on different amounts of water, and that is variable rate speed control. If I want to get fancier with a variable rate zone control, that's more complex and more expensive. There are commercial packages available. If I want to get really intense in changing the varying the rates, the amount of water I'm pumping, it gets a little more complex in the design because if I change the flows very much, I'm going to need probably a variable frequency drive. If I have a electrically powered motor, this is going to add some more electronics, some more valves, and of course more costs. But it's achievable. You can do that. The prescriptions are the limiting factor for a lot of these. Many of the variable rate irrigation prescriptions are based on either EC, electrical conductivity maps of fields, which is basically a proxy for soil texture. And these don't change much. And so I could have a variable rate irrigation map that I just stick with throughout the whole season. But if I need to have a more responsive prescription, that's a little bit more challenging. And there's a time delay, there's a cost associated with an expert to do that. And so several groups are working on automating those prescription updates. And these can be near real time or real time in response to field conditions. So if I have different maturities of a crop, for instance, or a different health of a crop, I could change that in real time. And I'm going to expand on that in a minute, but some examples of some who've been working in this area. Susan O'Shaughnessy, who just retired from USDA Agricultural Research Service in Bushland, Texas, working with Steve Evett and others. I'll show you what they're working on, and I have that. They've got some really neat stuff, a neat package that's been tested in several states. I'm not sure if it's ready to be commercialized, but it is very close. I have been working with Dr. Thomas Marek and Dr. Jiang Hu and others with a real-time variable rate irrigation for center pivot and subsurface drip irrigation. And of course, there are others. Other universities are working on this, and obviously other industry providers are working on this. So it's exciting. So part of being able to do that is data acquisition and communications. We have a lot of sensors and increasing sensors all the time. Some of those are in field, like in a soil moisture sensor or a plant canopy temperature. Some could be remote, and that could be weather stations nearby or even satellite-based data. I marked through that manual data collection because, by golly, it's fun to do that. Manual data collection is time consuming, it's challenging, it's hard to find, it's just inconvenient, basically. Hard to find people that want to go out and do that. If I want to get an NRCS equip cost share for sensors, they need to be telemetry capable, which is a good idea because that means you're more likely to use the data. You're more likely to collect the data and use the data. If I can download it on my phone, if it goes up to the cloud from my system and comes to my phone, I'm a lot more likely to use the data. Wireless sensor networks, again, I talked about that a little bit. There are increasing options available. They're off the shelf now, so they're more cost effective, and it's a cost effective way of monitoring multiple sensors and sites within a field. I don't have to have separate subscription services to be able to use multiple sensors in the field. Another great tool is the low-powered wide area network gateways. These are neat because I can connect multiple fields within a several mile radius if I have line of sight. And so I can, again, that increases the flexibility that I have and decreases cost because I just have to have that one gateway to collect from multiple fields. And we're doing that at Bushland, Texas at our research farms. Kind of fun. Now, these are just a bunch of graphs I threw in from various sources, but what the point I'd like to make here is as we're advancing in our irrigation technologies and controls, we're aware that we have a lot of applied research programs that have support data. We have irrigation recommendations, crop management recommendations based on research from a lot of different sources, from universities, from USDA Agricultural Research Service, from seed companies, lots of different sources. And we have published papers, we have lots of information available to us. The trick is, how do I incorporate all this knowledge into a decision in the field? How do I get those data, translate those into decisions? I also have solid background. These are just slides. If you've seen my presentations, you've probably seen these before. We have a lot of background information on soil water holding capacities, crop water use, irrigation capacities. So we have a lot of this background information that is fundamental to crop water management. So how do I get the information available, plug it into this background information and use it? Well, that's where these models and these advanced technologies come in. And there are a lot of different tools and packages available from public and private sources. I've just put a bunch of logos here. Some of these should be familiar to you. The top smart irrigation apps, University of Florida with University of Georgia put together several irrigation scheduling tools. Were really nice to have. They've got a lot of horticultural crops, but they also have some agronomic crops as well. The CanSCAD and Kansas State University models. I showed you that their mobile irrigation lab website. They have several other tools that are available. University of Nebraska is doing some great things. And then I have a bunch of companies listed here. All of these are companies that have advanced irrigation technologies, sensors, models, controls, wireless sensor networks, all of that. And you can adopt these in from the very basic monitoring, is my pivot on or off, to much more elaborate and much more sophisticated models. So anyway, just some examples. These are commercially available right now. Some approaches to precision agriculture or precision irrigation. If I want to try to incorporate all those, the data, the background knowledge, the research, incorporate all of that, I can simplify a little bit here. If I have soil water sensing, that can be in-field or remote. There are groups working on estimating soil moisture by satellite. Okay, it's not as accurate yet, but I can get some ideas. Then I'm going to throw that into a water balance or a depletion threshold, like our management allowable depletion we talked about earlier. Plant sensing, I have a lot of remote sensing options there, looking at canopy temperatures, reflectance, water status of our crops. We talked about those earlier. Weather data, we talked about that, getting direct measurements in the field, or I can have regional or other networks. Even the crop ET that I talked about earlier, that was, it's a ballpark estimate, but I have those options available. And of course, models using machine learning or using a mechanistic model. So I have these models available too. All those, I plug the data into a dashboard or controller to come up with a decision to irrigate or not. So I told you I'd talk a little bit more about that, the automated variable rate irrigation prescription. This is the one that Steve Evett, Susan O'Shaughnessy, and others developed. It uses wireless sensor networks in the field. So you've got your soil water sensors, your canopy temperature, infrared thermometers, or your IRT sensors, weather instruments in the field, and of course, some remote weather sensing as well. Use those data to calculate. They use those data to calculate the crop water stress index. It's just a number that takes all these factors into account using the weather and canopy temperature data. That crop water stress index is integrated into a single crop stress index for each measurement zone in the field. So I could have multiple indices within the field, just for the different zones that I want to irrigate. The size of those zones depends on how fine I want to get that grid. Maps of canopy temperature are made available through visual inspection, and then I decide whether to irrigate and how much. The irrigation manager can upload the resulting prescription map, and I'll show you what that looks like. I grabbed these graphics, adapted them from their publication that I showed you below. That's Ken Stone's publication. But this is the USDA ARS Smart Pivot System. So the yellow circle, I've got those canopy temperature readings. I use those to to estimate or calculate the crop water stress index, that red circle there. So that's the whole center pivot irrigation system with the different little areas with different colors. Those have different crop water stress indices. And then I use that to calculate a variable rate irrigation zone to tell me how much to irrigate these different systems. And then it plugs in automatically into that irrigation controller and provides different amounts of irrigation to the different zones as needed. So it's pretty fancy. It's been tried and tested in South Carolina, Mississippi, I believe Kansas, as well as Texas. This was a collaboration between USDA, ARS, and Valley Irrigation. So anyway, that's just an example of how that's used. It becomes all the hard math is done in the background. So the end user just ends up with that map. They use that LoRa gateway, the low power long range gateway system with the wireless sensor telemetry to get the data to the controller. They use multiple wireless infield and other communications that have recently become available. So 20 years ago, you couldn't do this, but now we have the capabilities of off-the-shelf technologies that we can do this. This allows the users to use a remote cell phone or tablet computer to look multiple irrigation systems, multiple zones for your data acquisition. And the publication is cited there. We can get that from the ASABE, from their technical library. And if you need help accessing that, please let us know and we will get it for you. Stay on there just a minute in case somebody wants to see it. Now, new technologies, including the wireless sensor networks, all of these things I've been talking about, they integrate that available knowledge and the background information into management decisions. So they've automated a lot of the what-if scenarios that we use when we're doing our irrigation planning and scheduling. We have applied research programs that they continue to work to advance these technologies and recommendations. So as crops advance, as the genetics advance, we continue to work to try to further refine these recommendations and improve crop water use efficiency. So it's an ongoing process, but we've made a lot of progress in recent years. Of course, I'm going to acknowledge that crop selection and traits, that integrated crop management, which includes all of your integrated pest management, your fertility, as well as your water. All of these things are key to success in water limited production environments. And so all of these work together. Have to give credit to our brethren in other disciplines. So I really appreciate their input. Finally, I wanted to show you another publication that is free. But castscience.org is an organization that puts together issue papers, information for the public that addresses issues of importance to agriculture and natural resources more in depth. So they have authors from across the country, even internationally, providing input into the questions that a lot of our stakeholders are asking. And this particular paper was led by Suat Armak, who I cited earlier. But the list of authors, we have several universities represented here, as well as industry. And that publication is free on the Cast Science website. You could just go to castscience.org, and in the search, you could enter irrigation, and this will be one of your main options right now. So it's Precision Irrigation Management is the title of that issue paper. And when we released the paper, when it was published, we conducted a webinar, and that is linked on YouTube. You can get to it from that castscience.org page, or you can get to it from YouTube at this address. So this webinar presented highlights of that paper. So I encourage you to take a look at that as well. It addresses economics, different precision irrigation technologies and tools from a lot of different authors. And finally, and also from that paper, adapted from that paper, I just wanted to summarize some of the precision irrigation technologies and practices that are included in what we call precision irrigation, including pressurized irrigation systems like sprinkler and micro irrigation. We can even have technologies, advances, and practices that improve surface irrigation. So it's not just what we consider pressurized and high-tech irrigation, but also your surface irrigation can be improved with precision irrigation. Improved nozzle packages, improved applicators, the way we apply the water, irrigation scheduling tools we've talked about in previous sessions of this webinar series, variable rate irrigation, and the advanced smart irrigation controllers and automation. So all of these are addressed to some degree in this paper. Again, just summarizing again, going back to all those inputs that we put into refining for precision irrigation. What we're doing is we see an evolution of the sensors and communication technologies, which really has helped us to be able to do the things. Years ago, we said, what if we could do XYZ? Well, now we can. And now we also have the big data and analytics and machine learning to help us digest all this data into a decision. And then we have internet connectivity to make it a lot easier to get the data up and back in a convenient format for us. So all of these things are relatively new developments that have come together to make what we've dreamed of for a long time possible. So I'm really excited about all of this. If you have questions, I'll be glad to answer. If I certainly, again, you can contact us anytime. And thank you, Christy, for your help and patience with this.
Yes, does anybody have any questions? I do have a question for you, Dana.
Okay.
How do you persuade a producer to use these new technologies when, commodity prices are high or low, sorry, commodity prices are low and inputs are high? How do you try to persuade them to use something like this to maybe make them or have them save some money?
That's a tough one and a very good question, Christy. And it goes back to economics. And will it save them time? That's very important too. And will it save them money? EQIP cost share is, I keep saying, I'm not trying to get everybody to take money, but at the same time, EQIP cost shares have, and other cost shares, some of the groundwater districts and other sources have cost share programs and low interest loan programs. These help, I guess, take some of the sting out of the high capital cost of all of this. Some of these tools are really not that expensive. If I already have a center pivot irrigation system with a controller, some of these technologies are just add-ons. So it doesn't cost that much. The off-the-shelf technologies, what we were looking at with our development is a few $1,000s for a center pivot is plenty. The sensor costs are there, so you need to be able to optimize how many sensors I need. We need to be able to, but a lot of these, like I said, their controllers are add-ons. And so you're not buying a whole new system. You're adding on some technologies or some electronics and some software onto it. So that's the main cost. Some of these are subscription services. They have varying levels of technical support. So if I want a really high level of automation, I'll probably spend more money on my subscription service than if I'm just checking to see if my pivot's on. So a lot of those guys already have those in the field. I think the next challenge is if the tools are easy to use, that's another barrier. Is we all know that people's time is very valuable. They don't have a lot of free time to be learning new gadgets. If the new gadgets aren't going to save them time and money, they don't want to do it. So I think the cost effectiveness, demonstrating that is important, and just helping them to use the capabilities that they already have on their systems that they may not really fully understand. Does that help?
Yes, thank you. And it looks like we might have a question coming in the
Okay.
chat. I see some typing going on.
I'm going to stop sharing so I can see.
Also, feel free to unmute if you would like to ask a question.
Oh, that's a good question, Joe. Do the commercial packages tools typically report amount of water saved? Probably not directly. I think what you can do is if I compare my schedule, what's a typical schedule? That's the problem. There are reports from demonstrations, applied research from mostly from other states where they did save a lot of water. You know, you can save an application or two of water or delay applications. And so you can back calculate what you saved. But that's really tough because each each season is so different that um, I see research projects that I think are a little bit, I see research summaries that I think are a little bit suspect when they say, okay, this is what I spent last year, and then I put a new piece of equipment on there, and this is what I spent this year. I can't really compare. I'm not comparing apples to apples then. So there are some larger programs like TAPS programs in some of the states that compare in the same field different practices, and I think those guys can give you some ideas. But as far as just putting on a package on my farm, what did I save? Um, that may take a little bit more calculation on your part to figure out, would I have irrigated if it didn't tell me, if it didn't tell me to irrigate, would I have irrigated anyway? That's one of them. Another technology that I mentioned earlier that we don't think is technologies, but for instance, your short season corn, it uses the same amount of water on a day-to-day basis, but with a shorter season, I have a shorter irrigation season, so I'm not irrigating as many times. So that's another way. That one's easier to calculate. I don't know if that's a good answer.
All right, any other questions?
We will follow later with some opportunities. Okay, thank you. Yeah, it is very, very variable, uh, season to season and crop to crop. We will be following up with some additional workshops and field days, other opportunities later on in the season. So watch for Christy's emails. She's really great about advertising and promoting everything.